Hello, this is Dr. Mulvad Shah from University of Engineering and Technology, Peshawar. It's a series of lectures for solution of differential equation. So I welcome to another video regarding solution of differential equations. We usually use Laplace transforms for solution of differential equations, which are used to model those phenomena which involves impulsive forces. Obviously, to use Laplace transform for solution of differential equation, it's important to know what is Laplace transform and how do you find Laplace transform of different type of functions. Okay, so what is Laplace transform? Laplace transform is obviously an integral transform which is defined for a function f of t. That function should be defined for all positive real numbers, could be zero as well, and it is defined as f of s is equal to the notation used for that is L f of t, or we may use a capital F of s. यहाँ से आगे हम जितना भी use करेंगे तो wherever you see capital F, that will be used for Laplace transform, where f of t, that will be a given function. Given function will be defined in a t space, whereas f of s, that would be defined in s space. So it's an integral transform. So we are taking integration from 0 to infinity and multiplying the given function by e power minus st, और फिर इसको आपने with respect to t integrate करना है. So you see, it's an improper integral, and whenever you have improper integral, there's always a question of convergence. So we say this Laplace transform for a certain function f of x will exist if this integral is convergent. Okay, so that's the definition. Integral from 0 to infinity e power minus st f of t dt, where we are basically, well, I'll be trying to explain how to find the Laplace transform of different functions by using definition of Laplace transform. I'll be also talking how to find Laplace transform of functions by using some specific rules as well. Okay, so we will first explain how to find Laplace transform of basic functions f of t. That means by using definition of Laplace transform to find Laplace of different type of functions. Okay, I may use only Laplace of something. I might be using the word transform separately as well, but that would be the same. Okay, so let's do some finding of different functions. So see Laplace transform of 1, that means f of t will be taken as 1. Okay, and you could see 1 is f of t, the formula, and f of e power minus st is simply multiplied with it. You know, integral of e power minus st, that would be e power minus st divided by minus s. So we could write that directly, e power minus st divided by minus s, and we take limit from 0 to infinity. Now if you put take t goes to infinity, whenever I say t, putting t go to infinity, that would basically means t goes to infinity. Okay, so if t goes to infinity, in that case e power minus st, that goes to 0. Okay, so we could simply take minus 1 over s as it is outside, because the limit is applied on t. There is no t involved in this one, so we simply have 0. And when you put t equal to 0, you get 1. So therefore, Laplace transform of 1, that's a constant 1, is 1 over s. The same thing can be extended for any constant function, like if we have a c function, where c could be any real number c. So its Laplace transform will be simply c divided by s, right? So keep this in mind. We'll be using this later on as well. Okay. The next one is p. We first derive Laplace transforms of our polynomials, and then talk about exponential functions as well. So you see, in this case, we just replace f of t with t. So the definition will give you integral from 0 to t, 0 to infinity, sorry, and f of t is replaced with t. Then using integration by parts, right? So integration by parts, which could be defined as integral u dv, that is equal to u into v minus integral v du, or we may use this rule as well, integral u into v dx, right? So we can simply say u, that's the first function, into v dx, minus integral du by dx into integral of v dx. Then we have dx again for the next one. Okay, so we can use this formula as well. So using this formula, what do we have? We see keeping t is our u and this one is v. So we have keeping this fixed integral of e power minus st is again e power minus st by minus s, then from 0 to infinity. And this is plus because of minus from the integration of e power minus t by s. And derivative of t is 1. So we have this one. And then integrating it again, right? So the integral of e power minus st, that will again minus e power minus st by s. It will become s squared. Whereas see, if you put t infinity, t goes to infinity, obviously as I said earlier. So this will give you 0. When t goes to 0, this will give you 0. So in this case, the limit is what? That is 0 in both cases. So the first term will give you 0. Therefore, we have Laplace transform of t, which is equal to 1 over s squared. Okay, so very simple and easy if you know how to integrate the given function. Now, what about Laplace of t square? So if you want to find Laplace of t square, the concept is exactly the same. What happens, we just replace this t with t square now, you see, and applying integration by parts, derivative of t square will be 2t, whereas integral in the first step and the second step will be e power minus st divided by s. Right, and this is what 2t e power minus st divided by s. 2t is coming from here. ये अगर हम t square के derivative लेंगे तो वो 2t आ जाएगा. And again we take limit at t goes to infinity. T square e power minus st will give you 0, and we take t equal to 0. This is 1, but this will give you 0. So in both cases, this term vanishes. And then we can simply take 2 common from here, and that will give you 2 by s e power t e power minus st dt integral from 0 to infinity, which is the Laplace transform of t. So we could replace this quantity by what? By Laplace of t. And we already found in example 2 or in 2 that Laplace of t is 1 over s squared. So therefore we have 2 by s into 1 over s squared, that gives the 2 by s cubed. So Laplace transform of t squared, that is equal to 2 by s cubed. Okay. Right, so let's find Laplace transform some further functions, that is t cube, which could be continued in a similar way. T cube e power minus t by expanding it by integration by parts, and then converting this integral back into Laplace of t square, putting the value of Laplace of t square to get expression for Laplace of t cube is 3 by s into 2 by s cube, that is the Laplace transform of t square. And इसके बाद हमारे पास क्या आ जाएगा? 3 into 2 that can be written as 3 factorial divided by s power 4. अच्छा, इसको हम 6 भी लिख सकते हैं, लेकिन just to extend this idea towards higher powers, what do? We simply express that as 3 factorial. Like you would say in similar way, Laplace of t power 4, okay, that will become what? That will become 4 factorial divided by s power 5. And in generalizing this, we can have Laplace of t power n, that is equal to n factorial divided by s power n plus 1. इसी अगर हमारे पास यहाँ पर t cube है, n की जगह t cube है, तो यहाँ पर आता है 3 factorial divided by s power 3 plus 1. Okay, the same thing is here. If n is integer, keeping in mind, in fact, non-zero positive integer. So Laplace of t power n, that will give you n factorial divided by s power n plus 1. Okay. अच्छा, what would happen अगर हमारे पास ये n जो है वो integer ना हो, तो फिर हम क्या करेंगे? उस सेंस में you should remember from gamma function theory that there is a relation between factorial and a gamma of value when n is integer, and that is what? N plus 1 gamma of this one, that is equal to n factorial. Okay, but that is true when n belongs to whole numbers. So in this formula, when we know that n is a whole number, we replace this one with what? With gamma of n plus 1. So we have Laplace transform of t power n, that is equal to n factorial by s power n plus 1. लेकिन ये जो फैक्टोरियल है इसकी लिमिटेशन ये है कि ये सिर्फ होल नंबर्स के लिए डिफाइंड होता है, नेगेटिव इंटीजर्स के लिए डिफाइंड नहीं है। तो इसी को हम आगे लेके जाते हैं और फिर इसमें कहते हैं भाई व्हाट अबाउट डी पावर ए, so that will be written as gamma of a plus 1 divided by s power n plus 1, which can be obviously used for any positive real number a. Okay, because gamma जो है वो इंटीजर के लिए भी डिफाइंड होता है और नॉन इंटीजर्स के लिए भी डिफाइंड होता है. Okay, you know that for gamma of n plus 1 that is n factorial, but that is only true when n is a positive and n is a non-negative integer. Okay. Okay, let's go towards exponential functions, right? Laplace of e power at. Again, the basic concept is same. You can simply take Laplace of a power t will be a power t, that's f of t, and this is the obviously kernel with it. So we have e power minus s minus at, which could be integrated as e power minus, this should be s minus a, sorry. This is e power minus s minus at and divided by 1 over s minus a. Limits from 0 to infinity. Now again, when you put infinity, t goes to infinity, this term will vanishes, and when t put t equal to 0, this will give you 1. So we have 1 over s minus a. That is the Laplace transform of what? Of Laplace transform of e power at. Right, so Laplace transform of e power at that is equal to 1 over s minus a. अच्छा, एक ऑपरेटर जो होते हैं यूजुअली हम इसको डिस्कस करते हैं whether operator is linear or not. So keeping that in mind, Laplace transform is a linear operator, which means Laplace of a f of t plus b g of t, that will give you a Laplace of f of t plus b Laplace of g of t, right? Because it's an integral transform and integration is also linear, therefore it is linear. Right, so let's use this linearity property for Laplace transform to find Laplace transforms of trigonometric functions as well. Since we know that Laplace of cos omega t, in fact cos omega t is equal to e power iota omega t plus e power minus iota omega t divided by 2, right? And then applying this linearity property, we could write that Laplace of this one plus Laplace of this one, where in this case a is equal to iota omega, whereas this is minus iota omega, right? So this is a for exponential, and this is minus, this is also a, another a. So we can have, by using Laplace transform, we'll be having 1 over s minus iota omega plus 1 over s plus iota omega. We are basically using the rule defined here. So altogether, we are having s divided by s square plus omega square, because just taking LCM of these. Okay. Okay, so Laplace transform of cos omega t, that is equal to s divided by s square plus omega square. Similarly, Laplace transform of sine omega t, which could sine omega 2 could be defined as 1 over 2 iota into e power iota omega t minus e power minus iota t iota omega t. So again, applying Laplace on both sides, we get 1 over 2 iota Laplace of e power iota omega t. The next one is e power minus iota omega t. And then we take the LCM of these two to get and dividing by 2 iota as well. So we have omega divided by s squared plus omega squared. Then it can be proved for a hyperbolic function as well. Sine cos hyperbolic at would be s by s square minus a square, whereas sine hyperbolic at is a divided by s square minus a square. तो अगर आप देख लें ट्रिग्नोमेट्रिक फंक्शंस और हाइपरबोलिक जो फंक्शंस हैं उनके Laplace ट्रांसफॉर्म सेम है. The only difference is what we are having minus sign for hyperbolic, whereas plus sign for trigonometric. चाहे वो cos के लिए चाहे वो sin के लिए, दोनों के लिए क्या होता है, सेम होता है. Okay, so let me do some exercises for here to find the Laplace transform of different type of functions. So f of t that given is minus 1 if t is between 0 and 1, where it is 1 when t is greater than or equal to 1. अच्छा, इस तरह के जो क्वेश्चंस हैं लेटर ऑन हम कमिंग लेक्चर्स में इस पर बात करेंगे We'll be using a unit step function to convert that into something in one line function, और फिर इसके बाद इसका हम Laplace transform find करेंगे. Okay, so how do we find Laplace transform of this function? By definition, Laplace of f, that is integral from 0 to infinity, okay, f of t e power minus st dt. Now, keeping in mind the function is defined in two steps, it's a piecewise defined function, so we need to split the integral according to the given intervals. So I'll taking 0 to 1 f of t e power minus st dt, plus then we take 1 to infinity, again f of t into e power minus st dt. Now from 0 to 1 the function is defined as 1 minus 1. So from 0 to 1 this is minus 1 e power minus st dt, plus from 1 to infinity the function is defined as 1 e power minus st dt, which might be integrated as the first one would give you 1 over s e power minus st, limits from 0 to 1, whereas the second will give you minus 1 over s e power minus st, but the limits are from 1 to infinity now. Okay, they are from 1 to infinity. Now, if we put s equal to t equal to 1 here, so that I give you 1 over s. It's e power minus s minus 1, because it gives you minus s. Well, putting t equal to 0 here, that will give you minus 1. And then we have plus, minus 1 over s. And if you put this one is infinity, t infinity, it becomes 0. And but if you put 1, so we get 0 minus e power minus s. Okay, which could be further simplified is that give you 1 over s e power minus s minus 1 over s plus 1 over s e power minus s, which could be further simplified as 2 by s e power minus s minus 1 over s. So that is the Laplace transform of this function. Okay, and if you have a function like f of t that is equal to t when 0 to 1 and it is 1 when t is greater than or equal to 1. So if you want to find Laplace transform of this one, so Laplace transform of f of t in this case will be, I'm going to directly integral from 0 to 1. The function is t e power minus st dt, plus integral from 1 to infinity. The function is 1 into e power minus st. Okay, now this could be integrated by using integration by parts, so I'll just keep that t fixed. E power minus st divided by minus s, limits from 0 to 1, minus integral from 0 to 1, derivative of t is 1, whereas integral of this is e power minus st divided by minus sdt. Minus this one is what? E power minus st divided by minus s, जिसको मैंने यहाँ पर minus लगा लिया है. And this is from where to where? From 1 to infinity. Now, if you put t equal to 1 here, it will give you minus 1 over s, okay, e power minus s into 1. Whereas for the second part, it will give you what? It will give you 0. Because when I put t equal to 0, that will give you 0. Minus and minus plus, and then we integrate that again, so we have e power minus st divided by s square now, in fact minus s square, limits from 0 to 1, oh sorry, from 1 to infinity, 0 to 1, sorry, it's the same thing, it's from 0 to 1, whereas this is giving, this will give you what? When you put infinity, this will give you 0. When you put 1, so it will give you minus e power minus s divided by s. This could be simplified as minus 1 over s e power minus s, and we put t equal to 1 here, so the math right is 1 over s square. When you put t equal to 1, that give you e power minus s, and we put t equal to 0, that give you 1 minus e power minus s divided by s. And this could be simplified to get the required Laplace transform of this function. Okay, and in this case, you see the function is defined as sine t when t is less than pi and 0 when t is greater than pi. So Laplace of f in this case, I could write directly from 0 to pi. I would say sine t e power minus st, where the second part will become 0. So all we need to find integral of this function e power minus st sine t, which could be found as by taking I just find a general rule for it. I is equal to integral e power at sine bt. Keep in mind इसके बाद जहाँ कहीं पे भी आता है तो उसको आप डायरेक्टली यूज करेंगे. So by using integration by parts, you see the first one is kept fixed, or maybe the second one is kept fixed, it's up to you. So that will give you e power at minus cos bt divided by b minus integral from a to whatever it is. This is again derivative of e power at is a e power at into minus cos bt divided by b. So we have 1 over b e power at cos bt minus into minus plus, and we can just take this a by b outside to get integral e power at, and then we have cos bt. Applying this rule again, you can find this formula directly from many books. E power at cos bt plus a by b, again using integration by parts. So we have e power at sine bt divided by b minus derivative of e power at is a e power at into sine bt divided by b. And this could be written as 1 over b e power at cos bt plus this will become a by b square e power at into sine bt, whereas this will become minus a square by b square into I, whereas the left side is also equal to I. Okay, and then you can simply take this from the right side to the left side, this one, to get a square plus b square. I just write it here. Well, the rest is straightforward then. So we have the left side become a square plus b square divided by b square I, and where the left side become what? Right side become what? 1 over b. I take e power at common, and then this becomes b e power at plus a e power at into cos b sin bt. This is cos bt. E power at is taken common. So this is cos bt, and this is a sin bt. But if you divide by b square, that's the LCM is b square. So you can cancel these together. So altogether, formula for this function becomes what? I is equal to 1 over a square plus b square e power at, that is b cos bt plus a sin bt. So we could use this integral directly by taking a b is equal to 1 where a is equal to minus s. So this will give you what? This is equal to 1 over a square plus b square, that is 1 over s square plus 1 into b cos bt. So b is equal to 1, so that is simply cos bt plus a, which is in this case minus s, so minus s into sin bt, और यहाँ पे साथ में आ जाएगा e power 8 minus st. As limits are taken from 0 to pi. So we can simply put this is t equal to pi. ठीक है, ये b1 के बराबर है, ये b1 के बराबर है, ध्यान में रख लें. So cos pi is minus 1, sin pi is 0, and then we put 0 to get cos 0 is 1, where sin 0 is 0. So we'll get something like e power minus s pi 1 over s square plus 1 अपनी जगह पे आ जाएगा. e power minus pi s और s pi, और यहाँ से 1 आ जाएगा, पहले केस में माइनस 1 आ जाएगा. फिर इसके बाद दोबारा 0 पुट करेंगे तो ये 1 हो जाएगा और ये भी 1 हो जाएगा. So we can simply get minus 1. Right? So that's the way to do it. Later on, we will be using unit step function to convert this function to simple form, and then we don't need to do these integrations. Okay, in this question, I'll be doing what? I'll be simply converting the function, the graph into function, and then the rest is straightforward integration. In this case, you see that the function is defined from 0 to 1 is 0, whereas from 1 to 2 onward, that is becoming what? इसको हमने define करना है. So you see ये point 2 2 है, whereas this point is 1 0. Okay, so equation of line will be by using y minus y1, right, divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. तो यहाँ पर y की तो as f of t आ जाएगा, whereas x1 y1 के हम accordingly वैल्यू लेंगे. So y minus y1, that means f of t minus 0. I'm taking this as my x1 y1, whereas this is my x2 y2. So f of t minus 0 divided by y2 minus y1, that means 2 minus 1, 0, sorry, is equal to x minus x1, so t minus 1 divided by 2 minus 1. So that will give you f of t is equal to 2 times t minus 1. And this is true when t is greater than 1. Right, so altogether we define the function is as f of t. This is 0 if t is between 0 and 1, and this is 2 times t minus 1 if t is greater than 1. And when we find Laplace transform of this function, so Laplace of f will be, the first part will be 0, so I'll just take integral from 1 to infinity 2 into t minus 1 e power minus st dt, which can be found by using integration by parts. Use IBP and then applying limit to get Laplace transform of this function. Okay, next one is given is f of t is equal to t plus 1 whole cube. Now, what do we do? In these questions, I'll be using the rules of Laplace transform. Okay, The first one is what? We can simplify this one is, this is t cube plus 3t square plus 3t plus 1. And then we find Laplace of f by using linearity property. It's Laplace of t cube 3 times Laplace of t square 3 times Laplace of t plus Laplace of 1. Right? So this will give you what? This will give you, see, the Laplace transform of t cube is 3 factorial divided by s power 4 3 times 2 factorial divided by s cube 3 times 1 by s square plus 1 by s. This is the Laplace transform of this t plus 1 whole cube, which can be further simplified by taking LCM of it. S power 4 is the LCM. We may simplify this as 1 over s power 4. So that gives you 6 plus 6s plus 3s square plus s cube. This is the Laplace transform of t plus 1 cube. Okay, now if you want to find Laplace transform of this function, so this could be found as expanding first this one by opening the square. So we get 1 plus e power 4t plus 2 e power 2t. I just, yeah, and then Laplace of f will be, Laplace of 1 is 1 over s, e power 4t, that will be 1 over s minus 4, plus Laplace of e power 2t will be 1 over s minus 2. Okay, right. If we have e power t minus e power minus t, again expanding this square, so e power 2t minus e power plus e power minus 2t minus 2. Applying formula a square plus b square minus 2ab. So Laplace of f in this case will be e power 2t Laplace is 1 over s minus 2 plus 1 over s minus plus 2 and minus 2 by s. Okay, which could be further simplified as well. F of t is e power t sine hyperbolic t. We first simplify, later on we'll be having rule for that doing it directly, लेकिन यहाँ पे हम इसको क्या करेंगे, इसको पहले सिंप्लीफाई करेंगे. We know sine hyperbolic t is equal to e power t minus e power minus t divided by 2. So this could be written as 1 over 2. When you multiply e power t inside, that becomes e power 2t, whereas the next one will become simply 1 because e power t and e power 2t will cancel each other. And then we find Laplace of f, that will be 1 over 2, it will be 1 over s minus 2 minus 1 over s. It's the required Laplace transform of this function. Okay, Laplace transform of sine 2t into cos 2t. Now first we multiply and divide by 2 to use double angle. So it's 2 sine 2t into cos 2t. Multiplying and dividing by 2, जिससे हम convert कर सकते हैं double angle में, that becomes sine 2 times 2t, which will be obviously sine 4t. अब Laplace find करेंगे, so Laplace of f will be 1 by 2 times Laplace of sine 4t, and we already derived that Laplace of sine omega t, that is omega divided by s square plus omega square. May cancel these together, so we have 2 divided by s square plus 16 is the Laplace transform of sine 2t cos 2t. Okay, I think we have done this question already. Going to do that again. So f of t that is equal to cos square t. So we don't have any rule for finding Laplace transform of cos square t directly, but fortunately we are having trigonometry, so we can just write this function as 1 plus cos 2t divided by 2. You should remember from trigonometry that cos 2t that is equal to cos square t minus sine square t, which could be simplified by changing this sine square into 1 minus cos square t to give you 2 times cos square t minus 1. And then if you want to simplify this for cos square or solving for cos square, it will give you what? It will give you exactly the same formula. So Laplace of f of t, if it was sine square t, you would have written that as 1 minus cos 2t divided by 2. Right? So Laplace of f, that will be 1 by 2 times Laplace of 1 plus Laplace of cos 2t. So you know Laplace of 1 is 1 by s, whereas Laplace of cos omega t is s divided by s square plus omega square. That's the Laplace transform of cos square t. Okay, if you have sine t plus 4, so again using trigonometry, you need to expand this first and then you would apply Laplace transform. You should remember that sine alpha plus beta is sine alpha cos beta plus cos alpha, which is t now, sorry, and to sine beta, where sine beta is 4. Keeping in mind cos 4 and sine 4 are constant. Right? So I hope you remember the formula. Use this formula sine alpha plus beta, that is equal to sine alpha cos beta plus cos alpha and sine beta. So applying Laplace on both sides now. So Laplace of f will be, see, this is a constant, applying linearity property of Laplace transform. So we have cos 4 Laplace of sine t plus sine 4 Laplace of cos t. Cos Now sine cos 4 is constant, so we have 1 divided by s square plus 1 plus sine 4 is constant, and we'll write that as s divided by s square plus 1, which might be expressed as 1 over s square plus 1 into cos 4 plus sine 4. That's the Laplace transform of cos sine t plus 4. Okay, obviously, in mathematics, whenever we define a transform, a direct transform, there must be inverse transform as well. So we move towards now how we find inverse transform, inverse Laplace transform, which basically means if you know Laplace transform of a function f of t, and let's suppose that is f of s, then the inverse Laplace transform of f of s will be what? That will be f of t. So we basically go from here to here. अगर आपको f of s पता है, f of t फाइंड करना है, तो दैट मीन्स कि आपने इसको इनवर्स अप्लाई करना है. ठीक है, तो इसको हम डिनोट करते हैं किस के साथ? दैट इज Laplace inverse, and that will be f of t. Okay, so since we know that Laplace transform of t power n for n belongs to n, that is n factorial divided by s power n, right? So Laplace inverse of n factorial divided by s power n plus 1 will be t power n. अगर इसका Laplace ये वाला फंक्शन है तो इसका इनवर्स होगा वो ये वाला फंक्शन. If this is the direct, okay, if this is the direction and direct way, this will be in the inverse way. Okay. Similarly, we have done that Laplace transform of e power at was found as this one. The inverse of 1 over s minus a will be e power at. Laplace of sine omega t was proven to be omega by s square plus omega square, but is if you see this one and want to find f of t, so this will be this function. Cos omega t was s by s square plus omega square, so Laplace inverse of this will be what? This will be cos omega t. And so on. We can use that for hyperbolic as well, sine hyperbolic at, cos hyperbolic at as well. So we're going to use all these later on whenever you see 1 over s minus a, so its Laplace inverse will be simply e power at. Okay, so ये भी ध्यान में रख लें कि इनवर्स ट्रांसफॉर्म जो है वो भी लीनियर ही होता है जिस तरह से डायरेक्ट ट्रांसफॉर्म लीनियर है. So let's do some example. Let's suppose we want to find this Laplace inverse of a function s square plus 6s plus 9 divided by s minus 1, s minus 2 into s plus 4. Keeping in mind कि Laplace inverse में मोस्टली जो यूज होता है वो पार्शियल फ्रैक्शन का ही होगा. तो पार्शियल फ्रैक्शन जो है यू नीड टू अंडरस्टैंड दैट, and for that purpose I already uploaded a video which is explaining shortcut methods for finding partial fraction. Okay, so in this case, if you see s square plus 6s plus 9 divided by s minus 1, s minus 2, s plus 4, we first take the partial fraction of it, which is usually taken as a divided by s minus 1 plus b divided by s minus 2 plus c divided by s plus 4. But we find their values directly. अच्छा, वो कैसे आपने सिर्फ समझना है यहाँ पे। अब इसमें मैं क्या कर रहा हूँ, फर्स्ट फैक्टर में अगर आप देख लें तो हमने s माइनस 1 को छोड़ दिया है। इसी यहाँ पर जो है फर्स्ट फंक्शन में यहाँ पे s माइनस 1 मौजूद है, लेकिन जब यहाँ पे हम आते हैं तो यहाँ पर s माइनस 1 को खत्म कर दिया और उसको बाहर निकाल दिया। और ये जो वैल्यू बेसिकली आ रही है, क्या हो रहा है, ये है हमारे पास a की वैल्यू, यानी उसको छोड़ के इसे हम कहते हैं ना a डिवाइड बाई s माइनस 1 प्लस b डिवाइड बाई s minus 2 plus c divided by s plus 4. So the proper way, the lengthy way is multiplying both sides by s minus 1, s minus 2, s plus 4, and then equating the coefficients on both sides to get the value of a, b, c, etc. लेकिन यहाँ पे अगर हम शॉर्टकट मेथड, जिसको हम कवर अप मेथड कहते हैं, इसको यूज करना चाहें तो इस केस में हम क्या करेंगे, इस केस में हम जो फंक्शन आ रहा है ना आपके पास, ये जो फंक्शन है, सॉरी यहाँ पे ये जो फंक्शन है, फर्स्ट स्टेप में जो हमने ए के लिए लिया हुआ है, इसको यहाँ से यूजुअली हम डिवाइड कर देते हैं डिनोमिनेटर को, तो ये खत्म हो गया, इससे ये रह गया आपके पास, बाकी सेम रहेगा। और इसमें s की जगह 1 पुट करना है, तो 1 पुट करने का मतलब यहाँ से अगर आप s माइनस 1 को 0 पुट करेंगे तो s हमारे पास 1 आ जाएगा, तो ये 1 वहां से आता है। सिमिलरली b को फाइंड करने के लिए क्या करना है, s माइनस 2 को यहाँ से हटाना है, बाकी रह जाएगा s माइनस 1 और s प्लस 4, और पुट क्या करना है, इसमें s की जगह 2 पुट करना है, बिकॉज फॉर s माइनस 2 अगर ये 0 होता है तो s की वैल्यू क्या हो जाएगी, 2 हो जाएगी। तो इस फंक्शन में हमें 2 पुट करना है, पूरे में ऊपर भी और नीचे भी। थर्ड के लिए जब हम s प्लस 4 करेंगे तो ये हमारे पास क्या हो जाएगा, इसको हटा देंगे, बाकी जो रह जाता है इसमें s की जगह माइनस 4 पुट करेंगे तो ये c की वैल्यू आएगी, और जैसे हम रख लेंगे 1 ओवर s प्लस 4 जो है ये अपनी जगह पे आ रहा है, सिमिलरली 1 ओवर s माइनस 2 अपनी जगह पे आ रहा है, ठीक है, and so on, right? So once we put all these values in here, so we get the next value is minus 16 by 5 into 1 over s minus 1 plus 25 by 6 1 over s minus 2 and so on. तो ये वैल्यू यहाँ से आ रही है, अगर आप एक को एक्सप्लेन करूँ, ये वाला यहाँ पर s की जगह 1 पुट करना है, so we get 1 plus 6 plus 9 divided by minus 1 into plus 3. So we get this is 16 and this is 2, it is multiplied by this one. Okay, so we have sorry, it's 1 पुट कर रहे हैं इसमें हम, तो यहाँ पर आ जाएगा -1 और यहाँ पे आ जाएगा 5। ओके, तो we have 16 divided by 5 and -1 यहाँ से आ रहा है, so we see that हमारे पास जो a की वैल्यू है वो -16 by 5 है। सिमिलरली b के लिए हम यहाँ पे क्या करेंगे, s को 2 पुट करेंगे, so I just take 4 12 9, whereas this will be 1 and then 6, so this is 16 plus 9 25 by 6, and similarly यहाँ पे -4 पुट करना है। Okay, so once we have all these values, अब बाकी तो simple हो गया, applying Laplace on both sides, Laplace of s square plus 6 plus 9 divided by s minus 1, अब 16 by 5 जो है वो constant है, बाहर आ जाएगा by using linearity property, and we have then simple exponential functions. So we have e power t, e power 2t and e power minus 4t. ये जो हमारे पास एक्सपोनेंशियल आ रहा है उसका हम वही रूल अप्लाई कर रहे हैं कि Laplace इनवर्स ऑफ 1 ओवर s minus a that is equal to e power as. a नेगेटिव भी हो सकता है, पॉजिटिव भी हो सकता है, तो यहाँ पर अगर आप देखें तो a की जगह 1 है तो यहाँ पर e पावर t आ गया, यहाँ पर a की जगह 2 है तो यहाँ पर e पावर 2t आ गया, whereas यहाँ पे a की जगह -4 है, so we'll be having e power -4t. Okay, some more questions. Let's the practice question. Laplace inverse of s plus 3 cube divided by s power 4. अब इसमें हम क्या कर रहे हैं कि इसमें हम सिंपली पहले इसको सिंप्लीफाई करते हैं। I hope everybody know that इस क्यूब को बुलाना है, ओपन करना है, तो we get s cube plus 3 times into 3 square of s, then maybe 3 into 3 s square plus 3 into 3 square into s, right? and then we have 3q, everyone divided by s power 4. So the first step will give you what? Laplace inverse of 1 over s. 9 times Laplace inverse of 1 over s square. 27 times 1 over s cubed plus 9 by s power 4. Laplace inverse, Laplace inverse. Now this could be simplified as Laplace inverse of 1 over s is 1. 1 over s is simple square is t, whereas this one will be written as 27 by 2 because we need 2 here, 2 factorial, right? We need 2 factorial in the numerator, so we will multiply by 2 as well. So we get 2 into 7 by this one into t square. Whereas in this case, we will be having, we need to have 3 factorial. So multiplying by 3 factorial and dividing by 3 factorial as well. So we have 27, it should be cubed. Is 27 divided by 3 factorial, and then we get t cubed at last. Whereas in case of 1 over s square plus s minus 20, what do? We first find the partial fraction of this, and let me consider this one is 1 over s square plus s minus 20. This partial fraction will be s square plus 5s minus 4s minus 20, which is 1 divided by s plus 5 into s minus 4. And then by again using partial fraction, so 1 over, this can be written as 1 over s plus 5 into s minus 4 by using cover up method. How do you find it? We simply take 1 over s minus 4 वैल्यू, ये जो पार्ट है इसको हमें छोड़ना है और इसकी जगह लगाना है s इक्वल टू माइनस 5 इंटू 1 डिवाइड बाई s प्लस 5, ये वो a की वैल्यू आ जाएगी। दूसरे स्टेप में हम क्या करेंगे, 1 ओवर s प्लस 5 लेंगे with s is equal to 4 now, and this is 1 over s minus 4. So when you simplify this, this will give you 1 over minus 9 or minus 1 over 9 into 1 over s plus 5. This is 1 over 9 into 1 over s minus 4. And then when you apply Laplace inverse on it, you will get what? You will simply get minus 1 by 9 e power minus 5t plus 1 by 9 e power 4t. This will be Laplace inverse of this function. The same thing here, s square plus 1 divided by s plus 1, s minus 1, s minus 2. So same technique can be used as we have done in recent case. We see that पहले केस में क्या करना है, s को ड्रॉप करना है, पार्शियल फ्रैक्शन यूज करना है तो इसको छोड़ना है, बाकी हर जगह पे 0 पुट करना है, a की वैल्यू आ जाएगी। फिर इसको छोड़ना है, बाकी सब हर जगह पे -1 पुट करना है, b की वैल्यू आ जाएगी। फिर इसको छोड़ना है और s की जगह 1 पुट करना है, c की वैल्यू आ जाएगी, and so on. I hope you can do that. Just maybe pause the video and solve this question yourself. Okay, let's find this Laplace inverse of 1 over s square and s power 4 minus 9. So again, what do? We use partial fraction here. So starting with 1 over s power 4 minus 9, which could be factorized as 1 over s square minus 3 into s square plus 3. Okay, now we have a shortcut method, which is sometimes a Heaviside method. And how do we do that? If we have a function like that, p of x plus a and p of x plus b, ये दोनों सेम हो। इसका डायरेक्ट लेप्लास पार्शियल फ्रैक्शन होता है 1/b माइनस a into 1/p of x plus a minus 1/p of x plus b। ये एक्सप्लेन मैंने किया हुआ है, इफ यू वांट डिटेल्स वो आप जा सकते हैं, उसको जो वीडियो है उस मैं रेफर कर रहा हूँ, वहाँ पे जा सकता है। यहाँ पर अगर आप देखें इस केस में हमारे पास क्या आ रहा है, यू आर गेटिंग s square and s square, so both are same. So the partial fraction for this function will be 1/3 minus 3, because this is a, this is b, and then we have 1/s square minus 3 minus 1/s square plus 3. And that will give you what? It will give you 1/9 into 1/s square minus 3 plus minus 1/s square plus 3. And then we can simply find the Laplace inverse. So Laplace inverse will be what? By taking Laplace inverse of this one. So this will be 1/9, and Laplace inverse of this is under root 3 divided by a s square. In fact, इधर से 1/√3 मल्टीप्लाई भी कर रहे हैं और साथ में डिवाइड भी कर रहे हैं, इसको छोड़ दें। 1/√3, and then we have Laplace inverse of under√3 divided by s square minus under√3 square, minus the next one is again 1/√3 into Laplace inverse of under√3 divided by s square plus under√3 whole square. So the first one is what? It is 1/9 under√3, that is hyperbolic sine hyperbolic 3t under√3 minus sine under√3t. This is the Laplace inverse of 1/s power 4 minus 9. The same thing can be done in this question 5. Just pause the video and apply partial fraction to find Laplace inverse of this function. Again, in this case, you see we are having same p of x, p of s here, s square or this one. So the partial fraction will be Laplace inverse 1/9 minus 1 into 1/s square plus 1 minus 1/s square plus 9. So we have 1/8. Laplace inverse, this is sine t, and in this case it will be minus 1/3 sine 3t. Thank you very much for being with me for a while, and don't forget to like, comment, and subscribe. If you have any question, you can just go to the comment box and write down the question. Any question, obviously, it's not important कि सवाल लाजमन इसमें होगा। आप किसी बुक से, किसी पेपर से, अगर आप एग्जाम की प्रिपरेशन कर रहे हैं तो आप वहाँ से भी एक क्वेश्चन मुझसे पूछ सकते हैं, कमेंट में डाल सकते हैं। Okay, so thank you very much. See you in next video, which will be also about Laplace transform. That's a second part of Laplace transform. Okay, so thank you very much.